Hi guys, welcome to another video on the Eagletree Vector. Now I've had a lot of people asking me to go through some specifics about multi-rotor setup. A lot of people also see that the flight test guys have since done a bit of a kind of a setup video and a review. They talk a lot about the stick menus. As you've probably seen from my other videos, I do a lot about the USB and the Windows menu. Now, prerequisites for this video is you need to watch ideally the unboxing if you've never bought the Vector or you haven't bought the Vector yet, you don't know what you're going to get, but also the setup part 1. Setup part 1 is where I get the receiver and the transmitter talking to each other. We configure the buttons and the layout. I talk about fixed wing in the part 1 video. However, the only difference in the actual setup of it is the switch that is used for flaps in the fixed wing. That's actually just going to be used for a kill switch, which actually arms the motors in a multi-rotor. Other than that, the setup literally is identical. So have a watch of that video, get yourself set up, get it to a point where you've chosen an airframe by going to choose airframe, choose your multi-rotor, obviously based on the motor layout that you've got. Make sure your internal setup of the multi-rotor is all correct, and then do the RX analysis wizard. That will get you to a stage where we can continue talking about this. So now you're at that stage, what we now need to do is we need to run through the mode switches. And generally speaking, the Vector, it doesn't differ in many ways between fixed wing and multi-rotor, apart from the way it actually acts and obviously the mode settings themselves. The OSD for the most part is identical. In fact, it may well be completely identical, but obviously the way that an aircraft flies, the return to home setup, and some of the other flight control setup, that's all going to difference between fixed wing and multi-rotor. So that's what I'm going to kind of briefly go over as best as possible. As always, if there's any questions, either head to the forums where there's loads of information, or post a comment on the video and I'll try and answer it as best possible, or find someone who can answer it. I'd like to say at this point a very big thank you to John from Eagletree, who spent about 45 minutes on the phone to me via Skype, just discussing some of the various modes, so I could bring a video like this to you where I can talk about them with kind of clarification on what they do, because the manual is a little bit hazy. That feedback has gone back to John, he's taken that on board, and it may well be that they're going to make some changes based on that feedback. Anyway, let's get on to the modes. So first and foremost, let's just have a look at the drop down. So all the modes available, they are the same as what appear on the fixed wing, but obviously what they do is very different. So I'll run through them one by one. So the first one to talk about is 2D no-hold. 2D no-hold is basic stabilized flight. That is to say, when you take off, your multi-rotor is going to hover in a stabilized manner. It is going to be affected by outside sources like ground effect or wind, so it's not going to stay in one fixed position. However, it is going to stay stable. If you put any control input in all the way to the maximum, it will only tilt itself over to a specific angle which will prevent the multi-rotor from falling out of the sky. It is to say that it's not a 3D mode or anything like that. It is designed to keep your multi-rotor in the sky, however you are controlling it. Your throttle is controlling the altitude, so if you find yourself drifting down towards the ground, you need to just give a subtle increase in that throttle. That will lift it up, and also you are controlling its position relative to you. So if you leave it and a big gust of wind comes along, it will push it around. The difference between that and 2D plus hold, in 2D plus hold, again, you will find that wind and exterior effects will actually affect the flight of the aircraft. It's still stabilized. The only difference really is that it will hold altitude. The way it holds altitude is via the throttle switch. Basically, when you put your multi-rotor, let's say up to 10 feet, if you put your throttle at 50%, the Vector will say, okay, I am supposed to stay at this height. So it sees that your throttle is in or around the 50% mark, so it says, right, this is now, via my barometer, this is where I need to be. If you want to increase altitude, so let's say you want to go to 20 feet, obviously you would either give it a full blast throttle and it will fly up, or you can give it a subtle amount and it will increase. Again, the key is that when you put it back down to 50%, it will say, right, this is the altitude that I'm supposed to stay at. It's still going to get blown around, it's not a GPS mode again, but it is actually going to fix that altitude. So that at least gives you the ability of knowing it's not going to start hitting the ground if it's up in the air. Loiter mode is the actual GPS mode. In loiter mode, the GPS will acquire a satellite or a number of satellites. When you fly your aircraft and you fly out to a certain point, if you take your fingers off the control surfaces, the aircraft will actually stay in the position it is. So your multi-rotor will hover in the area of space that it last found. There are a few settings that you can tweak on how aggressively it will stop and things like that, which I'll cover later on, but for the most part it will stay where it is. It's the equivalent really, if you're used to DJI, of the GPS mode. So it will actually stay in a fixed position in space, it will stay at a certain altitude, and it will hover there. If wind strikes it or if it finds ground effect, it's going to fight against that because it knows that it's supposed to be staying in that one GPS mode. It's not a case of when you flick it into loiter mode that you have no control over it. It's not designed to just fix in one position. The idea is that you can fly it similarly in the way that you can fly in 2D mode, but the point is when you take your fingers off the control surfaces, it will actually stop flying in that position. So it is a very good one for beginners. I'll talk in a moment a little bit about why you shouldn't necessarily take off in loiter mode as a standard. This is on the advice of Eagletree actually, but for the moment anyway, that covers loiter mode. It's really the best mode for GPS fix. Cartesian mode and Cartesian loiter mode, which is actually shown as Cart-Loit here, are very similar. The idea of Cartesian mode is that if you imagine yourself standing behind your multi-rotor before it's taken off, you're facing the multi-rotor, the rear of the multi-rotor is facing you, the front of the multi-rotor, let's assume it has a camera on it, is facing away from you. If you take that aircraft off, obviously to move it away from you, you're going to push up on your elevator. It's going to go away from you. If you wanted to bring it back straight to you, you would pull back. By doing that, obviously if you haven't yawed the aircraft around, the rear of the aircraft is going to come back towards you and the front is, at the front and coming away from you. The idea of Cartesian mode is if you were to fly that aircraft out, say 100 feet away from you, and then you yaw around, so the camera is now facing you and the back of the aircraft is away from you. If you found yourself a little bit confused as to which way round that was, flick it into Cartesian mode, and what that now gives you the ability of is to bring the aircraft home to you by pulling down on the elevator. Now it sounds a bit confusing, you really have to sort of visualize it in your mind, but basically imagine that the camera is facing you, so you've flown out and the camera is now facing you. Normally, to fly that multi-rotor back towards you, you'd press up because you want the front of the multi-rotor to come towards you. By having it in Cartesian mode, it says, well hang on, I took off in a different orientation to this, so I know down with my elevator, down is towards home and away is away from home now. Now there are a few things that you need to consider with Cartesian mode, and it affects both Cartesian mode and Cartesian loiter. In Cartesian mode, it will not come back towards the home point. It is purely based on the attitude that it was sent out originally. So to explain what that means, let's assume you take off, again you're standing there, the back of the multi-rotor is facing you, the camera is facing away from you, you stand there, you hover up to 10 feet and you fly out 100 feet straight in front of you. You then put an elevator input in and you move sideways 100 feet. So you are now at a kind of a 45-degree angle. So the home point where you're standing is 45 degrees away from you. If you put it in Cartesian mode, it will, and you pull down towards you, it will always fly back in parallel to where you're standing. It will not fly back at that 45 degrees angle. So it's not saying, oh, come home. So it's not the same as something like DJI's home lock mode, where actually if you pull down, it will say, well, I don't care what your rate I'm in, I don't care what attitude the aircraft's in, I will always come back at the angle towards the home point. All this will do is it will fly back towards in the direction that Cartesian allows. So it's, like I say, it's a little bit complicated to imagine that, but the key is to remember that it's not going to come back home to you even if you want to do it. Now people ask, why would you want something like that? Well, the reason is actually that if you were, say, doing some video of yourself, and you actually wanted to view the point where you're standing, or the home point, then it's quite useful because you can put it in Cartesian mode. You can yaw the aircraft around so a camera is facing you, and then you don't have to reverse all of your inputs like you would otherwise. Takes a bit of getting used to, but it is quite a handy mode. My advice really, get out there, give it a go. It's not a difficult mode to master. It's stabilized, it's using 2D no hold in Cartesian mode, and it's basically using the Loiter mode in Cartesian Loiter. So that is to say, if you're in standard Cartesian mode, wind will affect it, it will move around. You are basically using it in 2D plus hold mode. If you are in Loiter mode, then it's going to have the same effect as Cartesian, but also it's going to remember the GPS coordinates and it's going to stay in that location if you take your fingers off the control surfaces. Polar and polar loiter mode are a mode that basically creates an imaginary circle around the home point. Now, anything beyond 10 meters away from you and you will be in that circle. The idea is that if you fly your aircraft out to say over 10 meters, so let's say you go again 100 feet away from you, if you then use an aileron movement only, the aircraft will go around the home point in a circular motion, so it will actually follow this imaginary circle. So normally, of course, it would just fly away parallel to you, but this will actually create this imaginary circle. Now, there are some things that you need to be aware with this. The yaw of the aircraft is still going to be controlled by you. That is to say, let's say you went out to your 100 feet away and you turned the yaw round so the camera is now facing you. If you purely use the aileron to actually move left and right, the multi-rotor will not yaw itself around to automatically point at the home point. So while the aircraft is flying around this circle, the actual yaw of the aircraft will not actually follow the inside of it. So you do still have to kind of control that element of it. However, it does mean that with a little bit of yaw adjustment you can follow that circle, and if you put an object inside that circle then you can actually follow it with your camera, which can be quite useful. The difference between polar and polar loiter, just the same as Cartesian and Cartesian loiter, is basically that in polar you're using just the 2D stabilized mode, which is affected by wind and external sources. When you're using polar loiter, you're actually using the GPS mode. So that is to say, when you take your fingers off the controls, it will actually stay in that fixed point in space via the GPS coordinates. Again, it's one of those modes you really need to just go out there, give it a try. It's quite a handy little mode for just sort of circling close to you, and if you get the yawing right, it can be quite nice to actually fly around an object, for example. The one thing that you've got to bear in mind is that when you come back within 10 meters, it will flip from polar into Cartesian mode. So even if you're in the polar mode via your switch, it will flip itself into Cartesian mode within that 10 meters. The idea being that obviously 10 meters is quite a tight circle to go around the home mode, and anything below that would be unwise to try and yaw around in a circle in that kind of radius. Center stick mode is one of the most fun modes to try your multi-rotor with. Now, it is an advanced mode and you need to be very careful when using it. When you have center stick mode activated, you will find that number one, as soon as you flick it into that position, that your throttle will become much more aggressive. You will also find that your movements on the pitch and the roll are much more aggressive as well. The key with center stick mode is it's almost a manual mode. So that is to say that if you were to give a full blast of aileron, rather than just moving the aircraft from left to right at a certain angle, it will roll the multi-rotor all the way over. So it's like manual mode. The difference between center stick mode and kind of a full manual mode is that when you release the aileron stick and it goes back to center, the aircraft will automatically self-stabilize itself. Now, the reason that this is really good fun is because if you're not actually quite confident enough to know that you can right your aircraft after you've done a full rollover, then this will actually do it for you. So the key is, if you're going to play around in this mode, get altitude, get high. The actual radius, there is a setting that can be changed to kind of create the aggressive nature of it, so how fast you will flip your multi-rotor over. The key is though, let's say for example you take off, you fly out 100 feet in front of you, you then go up to a good couple of hundred feet, make sure you're nice and high. If you then give a full aileron input, you will find that your multi-rotor will literally, it will roll itself all the way around its own axis and actually basically flip right over. Once you've got to a point where you're happy it's not going to completely stall, then if you release the sticks, you'll find that it actually self-stabilizes itself. So it will pull itself out of the dive, but it needs enough altitude to do it. I give you word of warning on this because I have pancaked one of my batteries that was underslung from underneath my multi-rotor when I decided to do this at a little bit too low an altitude. Hopefully I might even be able to show you the video footage of that. But it is great fun. If you've never used multi-rotors in manual mode before and you want to learn, this is definitely by far and away the best way of doing it, because it teaches you how a multi-rotor acts when you actually put the angles of attack over a certain limit. You can get great speed out of it, but you'll also notice with great speed comes great altitude dipping, so you just need to be able to manage it. But fantastic little mode if you want to learn. Return to home test is exactly what it sounds like. Basically, when you flick it into return to home test, it will do exactly the same as it would normally do if it lost signal. It will take the GPS coordinates that it had when you took off, and it will fly itself back towards there. Now, there are some specifics about the way it will do that, the speed it does it, the height it does it. There's much more to cover in the safety setup, which I will go through later on in this. However, for the basics, it will come back to the GPS coordinates of the home place. What it does there does depend on that setting, but this is the mode that you would use on a switch if you just wanted to make sure that you've got the ability of getting your multi-rotor back to you if you lose sight for whatever reason, or if your video transmitter glitched out, for example. 3D plus HdgHld mode is the most advanced of all modes. This is basically manual flight. You are controlling the multi-rotor, you control its attitude, and you control its stabilization. So if you were to take off and you fly out 100 feet, if you push forward on your pitch, you will find that when you actually go forward on your pitch, the multi-rotor is going to tilt forward. If you then bring it back to center stick, you're going to find that it will stay in that attitude. To correct it, you've got to do a reverse input, so you've got to actually come all the way back down in the elevator and you've got to actually self-stabilize it. So it really is for people who are used to flying in manual mode. What I would say is, if you are going to practice with this, first and foremost, get used to using it in center stick mode, which, as I've talked about, already has the self-stabilization. What this will do is that will give you the ability of at least being comfortable with a multi-rotor that's being used at various high attitude angles. However, what you need to remember is in 3D plus HdgHld mode, you have to do the stabilization of it. Now, there are some settings that will affect just how aggressive those angles that you can do and how fast, say, you can do a roll, and again I will cover that later on in this. But yeah, 3D plus HdgHld is for the most part the same as manual mode, like a KK board in manual mode, without any self-stabilization at all. Display off is designed for people who are using the OSD. Basically what it will do is when you flick it into display off, it will turn your OSD off, so you will literally just be looking out of the camera. Very useful if you know that you've got lots of battery life, if you've got a decent RSI signal, if nothing really is worrying you. The important thing is also that if you have set some alarms in the OSD, there is a function in the OSD setup which is defaulted to being on, which basically says if an alarm warning comes, even if you're in display off mode, bring the OSD back. Obviously, if you look at that and then you want to get rid of it, you can turn it back off again, but the idea is that you can actually get those warnings. So perfect scenarios: if you're flying, you've only been flying for a couple of minutes and you just want to use the camera to do all your flight with no distractions whatsoever, however you've got a battery warning light, then you can fly along with no OSD, no problems at all, and then when your battery's getting a little bit low, boom, your OSD will come back on, and as soon as your OSD comes back on, that tells you immediately that, well, hang on, something needs doing here, maybe I need to come home. So that's the display off mode. The final mode is the 2D plus submode. Now, 2D plus submode actually means 2D plus submode switch. What it means is that if you have one of your settings set to 2D plus submode, then when your switch goes down to it, so your main mode switch goes down to 2D plus submode, the first thing it's going to do is it's going to put it in just a 2D plus hold, basically, but it's then going to activate the other 3 modes that are available from your submode switch. Now, there's nothing particularly new in here, there's nothing different, they're just the standard modes. So there's the no hold, which is 2D no hold, 2D hold, Loiter, Cartesian, blah 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 blah, all the same as that. However, the idea is that if you've got 2 3-pole switches, or you've got a 3-pole switch doing your mode switch and a 2-pole switch here, that you will be able to actually have more modes available to you. So one of the most common questions that I get asked since doing some of these videos is, what is the best kind of complete set of mode switches to use from the get-go? Now obviously that's a difficult one to answer because it really does depend on skill set, it depends on how used to flying in 3D modes you might be, manual modes, things like that. However, I go really from the point of view of maybe you're a first-time pilot, maybe you're someone who's flown something like a DJI Phantom and you know the DJI methods. So from that point of view, I would say the best setup that I've come up with, and the one that I tend to use most nowadays, is what you've got in front of here. So to talk you through it, I've got, with all my sticks back, so that is to say, whenever I take my transmitter out of the box before a flight, I make sure that all my sticks are all the way back. That's kind of my safety mode. That means, as you can see on the right hand side here, my motor kill switch is killed, so nothing's going to happen until I actually do something with it. And then I also have it in 2D plus submod and no hold under this. Now the reason for this is because when I had the conversation with John at Eagletree, he advised that it's best practice, if possible, not to take off with a hold mode in place. It's not that you're going to have problems. I've done it a few times before. I've had no real issues with it. But he said the problem is that as soon as you take off, it's going to be looking at the altitude, and the problem is that with a hold mode, with an altitude hold mode, it remembers the altitude really quickly. So you can find that actually it will leap up in the air and then it will come back down again, or it will just do something that you don't want it to. So best practice is to put it into a no hold mode. So that's why I have my default setting to 2D plus submod with my first submod mode as no hold. So that is to say that my transmitter is saying, I am in 2D plus submode please, and I've got it set to no hold, so it's just completely kind of 2D stabilized flight. As soon as I take off, and as soon as I'm comfortable that it's up in the air in the way that I want it to, the next thing I would tend to do is flick it on the main mode switch down into Loiter. Using the GPS mode, that means that it's holding on the satellites. If I take my fingers off the sticks, then it's going to stay where I want it to. Obviously, if you've got a gimbal, if you're doing camera work, it's a really nice mode from that point of view. I've then got on my third position, so my, oh my god, something's gone horribly wrong, I've got to return to home. So because I like to fly a little bit further away than I probably should do with the VTX that I use, I generally like to have the ability of knowing that if I can just flick it into a return to home, even if I can't see out of the camera, that it's actually going to come back to me. In the sub modes, so when I'm actually in position 1, I've then got the option of polar. Actually for this I would probably have polar Loiter, because again I like the GPS fix, so I like to know that when I leave my fingers from the sticks it's actually going to stay in the place where I wanted it. And I also like having a bit of fun, which is the center stick mode. So generally speaking, probably I would say 80 to 90% of all my flying is done in Loiter anyway, However, when I want to, I just flick it back and I say, right, I'm going to have a bit of fun in centre stick mode, or I might want to try this radius around me in polar loiter mode. Again, it's really up to the user, but that's what I would go with as a starting point and see how you get on from there. The other thing to remember is that you do have the motor kill switch. Now, I've actually got mine set to a 3-pole switch, but it actually functions from just the 2 poles of it. It's either on or it's off. Again, because I have mine set pushed back whenever I take my transmitter out of the box, that means to say that I can't arm my vector at all until I flick that switch down. Now, one thing I would mention with the kill switch, again on the advice of John, is that if you were flying, if you're in the air and you're a couple hundred feet up and you accidentally flick this off, it will shut down the motors. If you flick it back on quick enough, it will actually reactivate them. It will actually bring it back, so it won't be a case of you've got to rearm them or anything like that. You do have a small amount of time. As I said to him at the time, and we had a bit of a chuckle about it, it's not something that you want to really try and test, and it's not something that I'm going to go out there and try and test to see how quickly I could actually get the aircraft back to level flight if I actually killed the motors. Be aware of it, put it on a switch that is a little bit far away. The other thing to consider, of course, is that if you've got a few potentiometer switches that will stay in a fixed position, so I'm just fiddling around with my rear switches on my my Futaba 14SG, what you could do is you could use a potentiometer. That means that you can't accidentally flick it. You have to physically rotate it to be killed or not killed, basically. So that's one option to you. Anyway, that's the mode switches all looked at. Now we'll go into some of the other features that are available for Multi-Rotor. Staying with the RC configuration screen just for the moment, the only other things that you really need to look at here are just down here. We've got disable stick when in menu, and we've got disable menus when flying. These are obviously options for actually changing into the menu state when you're actually in flight. So if you're using the OSD, if you flick your toggle switch, you can actually get into the menu. Obviously, depending on what you're doing and where you are with your aircraft, you don't necessarily want to be able to get in there if you did accidentally flick it. So these are the two options that are available there. Other than that, literally, the only other thing that's worth mentioning is that if you've got a transmitter and a receiver that has a specific RSI channel, then this is where you would set it. It's not default set up as part of this. Obviously, I'm using the S-Bus through the Futaba, so RSSI is a general RSSI more than anything. But that's the other thing that's worth mentioning on this screen. Moving then into the flight controller setup. Now this is where you can tweak your gains, this is where you can do a lot of customization. The one thing I would say is that for the most part, and again this is going on the advice of Eagletree themselves, who have obviously done a huge amount of testing, more than I have, is that for the most part, most standard multi-rotors that haven't got weird configurations will fly very well out of the box. I suggest that before you even look at any of this stuff or even think about changing any of it, try it out, give it a go, fly it, see how it reacts. Anything after that comes down really to personal preference. Gains is not a subject I'm going to go into massively on this, because you can read thousands of pages of forum threads and you'll find for every 1,000 pages you'll find 1,000 different views on what's good and what's not. Generally speaking, from my own personal preference, gains really comes down to how you want your aircraft to fly. If you want it nice and twitchy, if you want a sports flyer, then some high gains in various axis will actually be quite good. If you want a nice sluggish, slow moving aircraft that doesn't have a lot of vibration when you're actually putting control inputs in, then sometimes low gains can be quite good. That's a very general outlook on it. If you go too low with your gains, or if you go too high with your gains, you get oscillation, you get problems like that. For that reason, that's why I say leave it as standard. If you do decide that you want to fiddle with your gains, and your general gains I'm talking up here, my advice to you is use a potentiometer knob, which we've got set up. If we go back to RC configuration, I've got a potentiometer knob that can be used for gains. In here, you use a little drop down menu and you say, yes, I would like to adjust my pitch gain via the potentiometer knob. Now it's very easy to say, oh, I'll tell you what, I'll adjust all of them, I'll set them all to be on that knob. My advice from my experience of messing around with gains is do one at a time. Don't do them all at the same time. Your aircraft, your CG, all of the equipment that's on it will cause an effect on what happens when you change one of these gains. It's better to kind of get that one, so pitch, that means forward and backwards, put it on your potentiometer knob, fly it, put it at 50%, dial it up a little bit, you'll see what reaction that shows, dial it down if it's too aggressive or if it starts oscillating, get it to a point where you're happy that it's doing what it wants to, then ideally land it, change it, go on to the next one, fly it, land it, change it. It takes time. Sometimes it's worth it. From my experience so far with the Vector, with a well-balanced quad, you don't need to do it at all. It flies really good out of the box, but again, it's always personal preference. Below that is the advanced gain settings. Now the advanced gain settings, again, even more so than the general gain settings, this is where you really need to tread a little bit carefully if you don't know what you're doing. Put it this way, the conversation that I've had with Eagletree, the suggestion was, most people will never need to even go into these things. There are settings that you can do if you've got a very strange CG, if you've got potentially a dead cat and you needed, you found that the yaw wasn't working right because actually the trigonometry between the motors was slightly off, like you can do with the KK2 board. These are places that you can do it, but again, I don't have the expertise of doing it, and I would strongly suggest if you're going to look at this, go to the forums, ask the questions, get people's advice who have actually played around with it. Generally speaking, you're not going to do it. The only other thing in here that is worth mentioning is the position hold gain and the loiter braking aggressiveness. Loiter braking aggressiveness, of course, means that when you're flying in loiter mode and all of a sudden you take your fingers off the sticks, it's how quickly the multi-rotor will kind of put the brakes on. How quickly it will say, oh, this is the GPS coordinate I've got to stay on. If you've got it on a high gain, obviously it's going to put the brakes on very hard. If you've got a low gain, it's going to do it nice and slowly. Maybe worth playing around with. From my point of view, I would say it's fine as it is. Again, it's all personal preference, but give it a go. Position hold gain is very similar to that, and again, you can read the little thing in the bottom right hand corner here on what all of these various settings can do. Underneath that, the 3D direct rates. This is where if you're flying in 3D plus heading mode, you can actually basically change the aggressiveness of your action. So if you wanted to flip, as it says here, example, if you wanted your multi-rotor to attempt a 360-degree flip in the roll axis in 0.5 seconds, in other words, when the aileron stick is fully deflected, set roll rate to 2 Hz. Obviously it's at 1 Hz at the moment. So if you want your multi-rotor to flip quicker, then do that. One thing that I did get answered, because I asked the question of John, is that when you're in center stick mode, this also affects center stick mode. I found that the rolling in center stick mode was quite slow. There was quite a large radius of the roll, and from my point of view, I would prefer my multi-rotor to really flip around quickly, because for that reason you usually lose a little bit less altitude, and also it's easier to kind of get control of it if it does flip quite quickly. It suggests here that it's only for the 3D heading hold mode, but actually when you're in center stick mode, when you deflect the sticks all the way to their fullest extent, it's actually basically saying, okay, I'm no longer in center stick mode, I'm in 3D mode until you basically take your fingers off that stick and return it to center, at which point then it will go back into stabilization mode. So bear that in mind. So it's worth fiddling with, but again, if you're going to fiddle with any of these settings, try it as stock, get it in the air, get confident with center stick mode first. Don't go straight into 3D heading hold mode unless you're really confident. Get high, try it, flip it, see how it reacts, see how your multi-rotor comes out of the sky. If you've got a heavy multi-rotor, it is going to fall very fast. Be aware of that. And then if you think you need it flipping a little bit quicker, then up this rate a little bit. Don't go silly. Don't suddenly put it up to 10 or something ridiculous like that. Do it one stage at a time, see how you feel, and then give it a fly. Underneath we've got other advanced settings. Now there's a few of these that are worth mentioning. Obviously auto disarm on landing, that's actually defaults to being off, so that is to say when the Vector believes that it has actually landed, it will disarm the motors. as opposed to you having to do it yourself. One that's on all the time, auto disarm on flip crash, very useful. So if you do crash, and as I say, I've already done this, it will detect, the vector will detect that it's upside down and nothing's happening, there's no control inputs, anything like that, and within a second it will disarm itself. Great thing about that is it means that your multi-rotor's not sat there twitching away with your ESCs getting an absolute battering because they're trying to move motors that can't move at the time. Allow fast arming, all that will do when ticked on is it will stop the little gap that you see between arming the motor, getting the pulses, and then the motor's actually spooling up. So it will actually remove the pulses and it will just go straight into arm mode. Enable Loiter wind rejection, that is to say that it will push against the wind, obviously that's defaulted to on. And then you've got vibration rejection, medium, low, high. I'm advised that a couple of these settings will probably be disappearing anyway in later firmware updates as they're not really relevant. The other thing to look at is maximum pitch and roll limits. When you're flying in 2D mode, you'll see that your multi-rotor will only pitch over or roll over a certain amount of degrees. That's where that is set. So at the moment it's got the defaults in there. If you want your multi-rotor to be able to fly a little bit quicker whilst it's going along the ground, you could increase those numbers a little bit and it will fly at a steeper angle. Bear in mind, as with any multi-rotor, if you fly at a steeper angle you will actually be coming down towards the ground a little bit steeper. So to stay level in flight you're probably going to need a little bit more throttle. So be very careful when you're adjusting any of these. You've also got a setting below it for what it will do during return to home. So the top one is for flight and the lower one is actually what it will do during return to home. Finally, the only other things to look at are the multi-rotor settings over on the right hand side here. Low battery auto land, that is to say that it will only allow a certain number of volts per cell. Once it gets below that it will do an auto land. That is defaulted to on, so you need to make sure, and I'll go through this in a later video, that you've calibrated your voltages correctly because you don't want to find that your aircraft is auto landing. Obviously if you do a lot of flying over water or people, it's much better not to have the auto land on because it doesn't care what it's going to land on top of. Sometimes it's better to brick your battery completely, just getting the last few volts out of it just to get you back home or back onto dry land or away from people that you might be flying over. Obviously that's something that I don't suggest you do anyway, but anyway you can actually set what stage that kicks in right here. But again, I will iterate the point, you need to make sure your voltages are right and you've got your calibration of your voltages right before you actually consider doing that. Idle throttle set in milliseconds. Basically the higher this number the faster your idle motors will be. Ideally you want to have an idle that is quite fast, but you don't want it to a point where when you actually turn your motors on and you're sitting there on the ground that it's actually trying to lift itself off the ground or fall over. Worth playing around with this setting because it is very different depending on your setup. If you find that you have to put a large amount of throttle in before it will lift off the ground, you could probably increase this slightly. Likewise, if you've got a very light multi-rotor, you may find that actually you need to reduce this a little bit so it doesn't take off when you're actually doing it. So now we move on to the compass and sensor setup page. Now you can see that enable magnetic compass is automatically enabled for multi-rotor and it gives you the instructions that you need to do in the field. There's a number of different ways you can do it, but certainly this way is actually the best. Basically you get out in the field, you flick the compass, the mode switch 1, 2, 3, 4, 5, 6, 7. That will activate a menu saying do you want to calibrate the compass, at which point you just flick the mode switch once more, as it says there, toggle mode once more. If you're looking at the OSD at the time you'll see that. Obviously my suggestion is to try and get used to being able to do this without looking at the OSD, because if you're looking at the OSD you might have a metal case, you might be standing by a car, you might be somewhere where you don't want to be. Basically, to do a nice calibration of your compass, get out in the middle of nowhere, try as best as possible. Don't do it in your living room, don't do it standing next to a metal shed as I once did and discovered what horrors happen when you calibrate a compass near large metal buildings. It destroyed my F450 at that time. So yeah, so get out into a nice clean open bit of field if you possibly can. You don't have to do this every single time you fly. There are mixed views on this one. My personal opinion is if you can calibrate your compass in or around the general location that you fly, and when I say in or around, I mean like within 100 miles of that location. If you can do it once in that location, and then you can store your aircraft where you aren't sitting it next to magnets or anything like that that could cause interference with the compass, there's no reason that you should have to do this compass calibration every time. If the compass goes out, you will actually get a warning. The OSD will actually give you a warning saying compass needs calibration, which is a really nice feature because it's something that doesn't always happen with multi-rotors. So just bear that in mind. Try and get a nice clean calibration of the compass and learn how to do it via doing the 1, 2, 3, 4, 5, 6, 7, wait a couple of seconds, 1. Then you do the spin, you hold it out, you have the GPS facing towards you, the arrow faces towards you, do a nice slow rotation around, then you face down just like the little chap over here on the right, and then you do a nice slow rotation. If you do that slow enough, it will do it, and it will complete 100% of the time. But again, it's worthwhile just doing it with the OSD or with a set of goggles on potentially, just so you can see exactly what it looks like and you can kind of get a feel for it. So moving to the left hand side, we've got the GPS fix quality settings. Now in multi-rotor, you do ideally need to have all of these as a kind of a minimum threshold before it will actually fly in GPS mode. It's not to say the aircraft won't take off, it won't stop you from arming or flying, but basically it will stop you from using any of the modes that actually use GPS, so especially Loiter, Polar Loiter, Cartesian Loiter, those modes that are actually using the GPS. Just run through them very quickly. Minimum satellite counts, obviously 6 is the minimum, that's just a recommendation, the more the merrier. Maximum HdgHld, this is the quality of the GPS signal, lower the better from this point of view, which is why it's on 2. It says down in the bottom bottom right hand corner that anything under 2 is highly desirable, less than 1.3 is very desirable, but may not always be attainable. Bear in mind also that when you do get up in the sky, you may get away from the horizon slightly. One thing that people always fail to remember is that GPS satellites aren't always directly above you, they're actually on the horizon line as they're coming around the rotation of the Earth. So potentially, if you've got lots of trees around you, things like that, when you get above those trees, you might actually get a slightly better signal. The one thing you've got to bear in mind though is that getting a signal on a multi-rotor that's moving around a lot might be quite challenging, so just bear that in mind. Again, the OSD is fantastic. If you're looking through the goggles, if you've got it on a monitor, it's going to tell you whether or not you can go into Loiter mode, and it will give you a warning basically. Seconds to wait post GPS fix, that's just designed so you don't suddenly lose the GPS fix that you had, and also you've got the require 3D GPS fix. And as you can see there, it says set this to yes if you wish to wait until a 3D GPS fix is attained. Okay, now moving below that, we've got the voltage stroke current calibration. Now this is quite an important one. If you head over to your overview screen, I'll just click apply on this, you will see on the right hand side multi-rotor settings. You've got your idle and you've got your low battery auto land, but you've also got present pack voltage. So this is what the Vector is seeing as coming out of the battery at the moment. So it at the moment is seeing that I have a battery pack that is saying that it is 12.45. Now I actually know for a fact, after putting a multimeter across it, that is incorrect, that actually I have a slightly higher voltage in that pack. So the Vector is thinking that my pack has less voltage than it was. Now if I want to up that rating, literally all I need to do, and the ideal setup, is to get a multimeter, get an accurate voltage from your battery, plug it in, and as quickly as you can head over to this. Now the main pack that's plugging in through the power pack is your motor voltage factor. Now basically, not too difficult, all you need to do is if it's saying that you've got too low a voltage like I have, all you need to do is you need to bump that figure up slightly. You can see it only goes up in a certain number. So if I put that up to 1.03 and then we head over, we click apply, you need to click apply every time, over to there, you can see now it's saying, oh, now the battery's got 12.56 volts. Now I happen to know that actually it's got 12.5, so that's too high. So I'm going to go back over and I'm going to say, okay, let's bump it down a couple of notches. Click apply, back over to the overview, and boom, I found the sweet spot, 12.5, and that's the same voltage as a multimeter is telling me that my pack has. Now, why is this important? Well, if it's a lot out, then you could find yourself in two situations. Worst case scenario is your Vector thinks you've got more voltage than you actually have. So when you're coming home, you can see your gauge is saying, oh, you're getting low, you've only got a certain amount of flight time left if you've got the flight time wrong, things like that. Unfortunately, what it doesn't realise is actually that pack's a lot lower than it thought it was. You're flying along and suddenly it can actually not maintain flight or the altitude that it's at, and you end up crashing your multi-rotor. Obviously, if you've got auto land on as well, that will only come down when it gets to a certain number of voltages, to a certain voltage per cell. So if it's waiting for 3.5 and actually it's down to like 3.2, then potentially it's not going to be flying at this point. So auto land won't kick in and it'll actually fall down out of the sky. They're extreme circumstances, but it's something that you really do need to be aware of. And obviously in the reverse, the last thing that you want to know is that the Vector actually sees that you've got a lower voltage than your pack actually has, because that means that your flight time is going to be reduced, because you're going to get that warning, or you're going to get that auto land kick in way before actually the pack has run out of milliamp hours. Now again, if you're new to all of this, I strongly advise get yourself a cheap but usable charger that allows you to see how many milliamp hours went back into your pack. Run by the 80% rule. That is to say, you don't want to use more than 80% of the total milliamp hours available in the pack. Run by that rule. When you charge your battery up after a flight, see how many milliamp hours you put back into it. If you find that you can increase that, if you found that you landed and there was still loads left in it, then you can do some adjustment. If you've got this calibration right, you should be basically in a position where that will be as accurate as possible, so you should be able to fly to 80% very easily, but it's well worthwhile just making sure you check that. As you can see, there's also options for transmitter voltage factor, camera voltage factor. Now these are all because basically the Vector has the ability of having two power sources. Obviously, if you've got a second flight battery, then you can change this, and you'll see on the OSD that the transmitter voltage can be displayed as well as the main pack voltage. If you find again that you run a multimeter across the transmitter voltage pack and you find that actually the transmitter is reporting back to the Vector that it's got, say it's a 12 volt pack and it's reporting that it's got only 11 when actually it's got 11.4, then you need to do some factoring in on this one here. I'm running actually both packs, so I just run with one single pack for both my video transmitter and my motor voltage. So one thing that I've got to look at still is what I'm seeing. So if I were to look at the transmitter voltage, chances are, because it's not matching up to this, that it will be reporting a slightly lower one. The thing to remember is that it's the motor voltage factor that is going to affect the auto land and things like that. Underneath this we've got other sensor settings, not really much to talk about there. Obviously you've got the option, if you've got a Spectrum flight log, then you can zero it once every minute as an option for people who are using a Spectrum. I have to admit I don't own one, so I'm not going to talk too much about that. And then you've got use MAH for motor battery gauge. That is to say that when you've got the motor battery gauge on the OSD, it's going to be using MAH. The other thing that you can consider if you've got a RPM, an RPM sensor, is that you need to calibrate it. You need to tell it the number of poles that the motor has. What are the poles? The poles are basically the number of kind of coil packs inside. So if you look at a motor from above, you'll see a bunch of coils, and it's the number of coils that are in there. Most motors for multi-rotors like this will probably be a standard 12. Again, if you need to change it, you probably know a lot more than even I do about all of this anyway, but that's why you would change it there. Okay, now let's move on to the final section, the safety setup. Now, return to home, there are various features in return to home, and they do differ slightly from fixed wing, so it's worth touching on these. Obviously, we've got an option of what we actually want to do when return to home is clicked in. Now, return to home, of course, can be clicked in via a switch, but it can also be clicked in if you lose signal. I'm using S-Bus, so basically the Vector says if I can't see anything from the S-Bus channel here, then I'm going to click into return to home. The options you've got are none. none, so do nothing. You've got land, which will automatically instantly land the aircraft, and you've got return to home. Obviously it will land on whatever is underneath it, so I strongly advise that you leave it as return to home, and it will make whatever effort it can to come back to the home point. As I just mentioned, below I've got the S-bus as the option, so that's actually what triggers for me the return to home if it's not my own switch. Now, fly home at this altitude, that is exactly what it says. This will fly home in return to home at an altitude of 60 feet. Obviously, if you've got high-rise buildings, if you've got lots of large trees or a mountain or something like that, then you're going to need to increase that before it comes back. And you've also got an option which is defaulted to no, which is automatically land at home point. So if you do want it to actually come down and land for you, then you just have to remember to tick that as yes. Otherwise, all it's going to do is it's going to come back to you and it's going to hover above your head at roughly 60 feet. Underneath that, we've got the maximum altitude and distance settings. So if you wanted to actually say, you know what, I've got a legal limit of 400 feet, I'm going to put 400 feet in there, then that's where you put it. If you put it into maximum distance radius of X number of feet, so let's say you didn't want to go more than 2,000 feet away from you, you stick it in there. Basically, either of these settings, if for whatever reason you breach any of them, it's going to put it into return to home and it's going to bring it back towards you. You can take it over at any point in time. It will give you a warning. The OSD will flash up saying that it's in return to home mode. If you've got the audio warning, it will actually say that return to home mode's in, and it will do that as an audio voice. And obviously you can take that over at any point in time, so it's just a little fail-safe there. Underneath that, we've got show advanced safety mode settings. Now this is where you can actually change some of the characteristics for return to home. Now this is probably more relevant to people who have got aircraft of certain sizes, certain weights and certain flying characteristics. As you can see, we can do a specific ground speed that it comes back. The higher that is, the faster it's going to be. So if you're using return to home because your battery is low, then if you've got that set very high, then it's going to come pedaling along and it might fall out of the sky because it runs out of voltage. So again, I would say see how this feels at 8 miles an hour and then decide whether you want it to be quicker, slower, anything like that. Desired climb rate, that means to say that if you were below 60 feet, which is the fly home at this altitude, then it's going to climb up to that. If you wanted to do it very quickly, you just bump that up, so this is in feet per second. Likewise, if you're at 1,000 feet in the air and it's going to return to home at 60 feet, then this is the desired sync rate. So be a little bit careful with this, because with a multi-rotor especially, if you put that up to 200 feet per second, then it's pretty much going to turn the motors off potentially. I very much doubt it will do. I very much doubt anyone's stupid enough to do that. But anyway, that's pretty much how that works. Nice little option down here is that if you've got an OSD and you just wanted to watch the return to home and you wanted it to watch it coming towards you through the camera, then you just click this on to say I want it to yaw towards home whilst in return to home. And then we've got over on the right hand side here, we've got the home altitude mode set. Now there's a couple of options here that I'm going to go over. Basically what this does is when you click it into normal, if you take a look at this diagram above us, you can see the diagram changes to help explain exactly what's happening here. Basically what happens is that you actually have a fly home altitude. Now that is set again up here. So at the moment we've got a fly home at this altitude of 60 feet. So this is to say at the moment it's going to fly home to 60 feet. If you've got this option set to normal, you can basically say that after it gets a certain distance away from you, so a certain radius, so from this example, when it gets within 400 feet, that it will then come down to the home RTH altitude of, and this says 60 feet. So actually, with the current settings that I've got here, it's going to fly along at 60 feet, it's going to get here to 400 feet, and it's going to continue flying along at 60 feet. However, if I said actually, you know what, miles away from me I've got some high trees, or I've got a couple of buildings that I need to make sure that I clear that, I'm going to say, well, you know what, I'm going to have that at 250 feet. That is to say that when it's flying home in this way, it'll be nice and high up in the air, it's not going to have any risk to people on the ground or anything like that, it's not going to hit trees. However, obviously when it gets to a point where I need to really see it, it's then going to say, right, I am now 400 feet away from the home point, I am now going to drop myself down to 60 feet. Obviously, you know, if you're standing in a park with lots of high trees and stuff like that, you've got to make sure that when it does come down to that radius that it's not going to be too low that it's going to start hitting things. But it gives you the ability of, as I say, of having a nice high-rise fly home. So if you actually like using return to home to just kind of take your hands off, look at the OSD, look at the output of the camera and enjoy the flight, then it's quite nice to know that you can have it do that at a nice high altitude, on the understanding that when it gets closer to home it's going to come down to a point where you can get visual reference of it, you can see the multi-rotor a little bit easier and you can guide it home. Underneath that you've just got a couple of advanced receiver settings. Does receiver support failsafe? I'm using S-Bus. Yes, it does. Simple as that. And you can also disable the failsafe RX glitch detection. This really involves some of the older style receivers that I understand have a bit of a problem. It's probably not going to be something that many people are going to be flicking on anyway. Again, have a read of the manual if you don't understand that and ask some questions if needed. So that pretty much covers all of the general setup for the multi-rotor. Obviously the main things to do are make sure that your transmitter and your receiver is all done. You need to configure your compass. I haven't done this at the moment. I obviously have done before, but I need to get out there and do that again. And obviously the other thing to remember is the rotation of your motors and where your motors sit. If you've got any questions on that, again, you can go into your airframe and you can see which outputs from the Vector need to go to which motor location. Make sure you get that right. First time I set my Vector up, being the person who's quite happy to admit his mistakes, I was using a 4-in-1 ESC and I managed to completely reverse wire it because it didn't have any actual any labels or anything like that on it, and as soon as I took off it flipped right over and broke 2 blades. So again, it's just worthwhile just bearing that in mind. One thing that you can do is a motor test. You can do that from the sticks menu. I've actually had a couple of problems with the motor test, which I'm talking to Eagletree on at the moment. However, the idea is that you can basically pulse the motor, which gives you the direction that it's going round, and obviously to make sure that M1 is M1 and M2 is M2 and not flip the wrong way round. So just bear that in mind. As always, if you get this wrong for whatever reason, if you find that something's rotating clockwise when it should be counterclockwise, brushless motors, there's 3 wires, all you've got to do is swap 2 of them over, boom, it'll go the right direction. So that's one for the people who haven't ever set one up before. Anyway, that's the end of this video. Hopefully that's been of use. Again, don't forget, setup video number 1 is where I do the setup with the RX and the transmitter, and also all of the OSD stuff that I've done in the later videos, the advanced OSD, the OSD setup, all of that stuff is relevant to the multi-rotors as well. This has really just covered all of the points that are slightly different or needed touching on for multi-rotors.